Hello world, this is Craig. Let's look a little more at this monitor, and specifically let's look at the commands that are available in the monitor. When we have a piece of hardware, we can write what's called bare metal code for it. So we write code, and that's my confidence test is an example, where that code does everything on that hardware, and there's nothing helping us. There's nothing helping with the print routines or nothing to help with any of the other I/O for that system. You're writing for the bare metal, and there's no operating system. The Resident Monitor is just a very basic operating system. So don't overthink that. It's just an operating system like Windows or DOS or any other operating system. But obviously, it's much simpler than most of those. But the Resident Monitor typically allows for things like bootloading, so you can get the processor up to a higher state using a paper tape or a cassette. You can load programs or a disk if it's a disk operating system. But in this case, the Resident Monitor has about 12 commands that we can use, and those are listed in the MOD80 supplement that's available on Charles's website. If you go up to page 20 of this, it has a user's guide for the monitor, and there's maybe 5 or 6 pages of this user's guide for the monitor. It lists all the commands that are available. We'll go through these, and I'll give you examples of all of them basically just in use. But there's the LOC, which locates the current pointer. The pointer is just what location of memory you're working on, typically RAM. In fact, I would say that you're only going to use the LOC with RAM because you use the LOC when you're about to put a program in. The DLP can display the location pointer. You can dump symbolic or you can dump octal. You can load octal. Loading symbolic you do following the LOC command. You can enter the edit mode. You can execute a program. You can copy a program, translate a program, set or clear breakpoints, or program your PROM. So the best way to do this is, let's actually do an example here. Okay, so this is our monitor window. When we start the hardware, it comes up with our dashes, and it's not much of a prompt, but that's it. It's just a blank line for the prompt. The first thing we're going to do is locate the pointer. So we type a LOC. As soon as we press a space, it recognizes that as a command, and it comes back with the asterisk. And what the asterisk is asking for is, what address do we want to locate the pointer to? So my memory starts at 050,000, but the first portion of that is used by the scratch pad and the stack. So when we write programs for this, I'm going to write them up at 050200. Okay, it gives us the lower half of that address, and it says, well, now what do you want to do? Well, we can just type in another command if we want. We can do a display the location pointer, and it gives us the location pointer, and it comes back. So we can either type another command here, or the real intent of this is now we're going to put a program in. So let's write a little program that just reads through a block of characters that are up in memory somewhere and displays that. So the first thing we want to do is move immediate into B. So let's do a MVI into B, comma 015. So remember, we're working in octal. We have to include the leading 0 on anything. So we load how many characters we want to output into register B. Now let's tell it where those characters are. We're going to put those into someplace a little higher, LXI into H. And let's say we're going to put those into 050250. Okay, so we move the HL pointer to that particular address. Let's now start our loop. We're going to move, oops, it doesn't understand MAV, so MOV. We're going to move into A, whatever is pointed to by that memory location. Next thing we're going to do is call. We're going to do a call. Oops, not going to understand that either. CALL. And our monitor has the same programs that it uses to output to the teletype. It makes available for us. And we can see that these are the subroutines that are available for us to use. We can save or restore the registers. We can read from the teletype. There's a delay loop. We can output the teletype. The teletype output routine is at 001133. Okay, so we want to call 001133. Then we're going to increment our pointer, point to the next memory location. So increment the HL pair. We're going to decrement our counter, which is B. And then we're going to jump, if not 0, back up to 050205. So you see we're going to jump back up to this move instruction if we haven't reached our terminal count. And if we have, then we want to stop. We don't want this to just execute the next command because we have no idea what that is. We want it to actually stop and return back to our monitor. So we end with a restart. Okay, let's see if we got that all in properly. Let's do a dump program symbolic. And it says, where do you want to dump? And we want to dump from 050200 to 050220. Okay, so there's our move immediate into B, our 015. Then we load the HL pair. We copy whatever is it pointed to by the HL pair into A. We call our teletype routine that's going to print that. We then increment to the next memory location. We decrement our counter. If our counter hasn't reached 0, we go back to 050205. If it has reached 0, then we want to do a restart 0. Okay, great. So that's our program. Now we have to put our data in. So let's go up to, where did we say we were going to put our data? At 050250. So let's load octal 050250. And we're going to load to 050, let's say 265. Don't know exactly how many we need up there, but okay, we have to, this is a little tricky thing. You have to put in a slash and a space before we can start our data. And now we can put in as many octal characters as we want. And we're going to type out hello world here. So we look at our ASCII table, the octal column. And so H, for example, is 110 and a space 105, 114, 114, 117, 040 is a space 127, 117, 122, 114, 104, and then we want to carriage return line feed. So 015, 012, and it still wants more, so let's just put in a no op. Okay, now let's look at our data. So let's DPO, dump program octal, or just dump octal, I guess, probably more appropriate. 050250 to 050265. Okay, so there's our HELLO space WORLD carriage return line feed. Oh, great. So let's execute our program. XQT, and the program was at 050200. And there's our hello world. So that's the obligatory program that we have to write when we first start a system up. So now let's tweak it because this isn't exactly what I wanted. I wanted the hello world to be on its own line. So to do that, we have to make two changes to the program. One is we have to tell it to output 2 more characters. The second thing we have to do is we have to add a carriage return line feed before the rest of the data. So let's do the first thing first. So to tell it to output the 2 more characters, let's edit, EDT, and we have to give it the address we want to edit, 050200. And what's there now? Right now there's the MVIB. Okay, we're going to let that stay. The next one is, what's there? That's our 015. So that we want to change from 15 to 17. So 017. We just type 017, hit the return. Okay, so now we could type the next value, but let's just do a dump symbolic. Oops, let me have to get out of that. Dump symbolic 050200, 050220, Okay, so there our MVIB has changed to 17. Okay, now we need to add 2 characters to our data stream. We don't want to retype that, so all we want to do is copy that or move it really. But let's say that we're going to use the copy command. So CPY copy. The first thing it asks for is where do we want to move our data to? Well, we want to move it up by 2 bytes. So we want to move it to 050252. Okay, now where's the data we want to copy? Well, it starts at 050250 and goes up to 0502 what were we saying, about 265. Okay, so it moved that block of data, and let's go back and confirm that. Dump octal 050250 to 050265. So here you can see that it preserved the first 2 bytes, and then it moved everything else up by 2 bytes, which is exactly what we wanted it to do. So now we can go back in and change those first 2 bytes. So let's go ahead and do that. Let's edit 050250. And that one was 110. We want to make that a carriage return 015. And the next one is, what was the next one? The next one's a 105. We want to make that a 012, which is a line feed. Okay, now we can, from here, we don't have to do a Control A to exit. We can actually tell it jump right to the run command by doing a @ sign. So we say @ and then we say 050 like that. Let me put in a 050. Oh, we forgot. I'm sorry. We have to execute XQT 050200. I think my 5's going bad. So there's my hello world on its own line, followed by the carriage return, followed by the restart. Okay, let's say something's gone wrong with our program. So what we want to do is put a breakpoint in so it stops at a certain point in our program. Let's look at our program up here. 050212 is where it decrements B, and right before that, or right after that, is the jump if not 0. So let's put a breakpoint in at, so breakpoint is SBP for set breakpoint. Let's put the breakpoint in at 050213. 050213. Okay, now let's look at our program. If we dump our program symbolic at 050200 to 050220. See, now we have our move, but look at what it's done here, right? When we get to our decrement, it took out our instruction, which was a jump, and it replaced that with the restart 0 or restart 10. So what the program is going to do is when it gets down to that point, instead of jumping, it goes to the restart 10, which is going to display all of our registers. So let's run this program. XQT 050200. And so here's our registers at that point. So it did the hello world, and then it showed us our registers. Let's do that again. XQT 050200. Okay, so it's printed out all the registers A through the HL pair, and then it prints out the memory location that's at the HL pair. So we can, if we look at our program where we have the restart, we loaded into B17, but then at the decrement, it's now 16. So that's correct. Register B is at 16. Register A should have the first character. Yep, so that has the 015, which is the carriage return. And the HL pair are pointing to 050251 because it's advanced. It's past the increment H, and so it's looking for the next piece. And then the memory that's at the next piece is the line feed, which is 012. And then those are our flags after that. So the breakpoint's a very valuable and useful thing when you're writing code. So let's clear that breakpoint by CBP, or clear the breakpoint. And it took our instruction that was there, our jump, and it put it back in. So now if we look at our code again, dump program symbolic at 050,200 to 050,220, we can see that it's taken that restart out, and hopefully it put back our jump instruction. Yep, so there's our jump, if not 0. Okay, so let's look at the commands and see if which ones we didn't use yet. We can display the location pointer. So that's where the location pointer is. We can set it, display it. Then we can do the symbolic program input. We did that. We can dump symbolic. We can load octal. We can dump octal. We can edit. We've done that. We've initiated a program. We've copied. Translate. Translate's one thing we haven't done yet. The purpose of the translate is if we write a section of code and then we're going to put that in ROM, for example, or we want to just move that code to someplace else, we have to make sure that our calls and jumps that are within our code move with us. Let's say that we are going to just translate our code that we have here. So from 050,200, let's say we're just going to move it up to 050,220. When we do that, this jump instruction, the jump if not 0, has to move with us, or it would jump back to the 050,205. So let's translate this code. And normally we would say one reason we would use this is if we wrote a program and now we want to burn that into ROM, we're going to translate the code, and then later we're going to copy that code or program that code into ROM. So let's translate now. TRN is the translate. First thing it's asking for, what is the beginning of the existing block of code that we're going to work on? And that existing block of code is at 050,200. Okay, now it says, where are we going to move that code? We're going to move that code to 050,220. That's going to be its new location. Now it asks for a memory address, a lower limit and an upper limit that says what's the size, or where is that block of code? Where that block of code is at 050,200 up through 050, and the last instruction is at 216. 050,216. Okay, so now let's go back and look at our code. So dump program symbolic at 050,200 to 050,220. So it didn't do anything with the LXI instruction because that's loading from RAM. It didn't do anything with the call instruction because that's loading from the ROM. But the jump if not 0 instruction, it moved it up to where we're going to move our code. So we're moving our code up to 050,220, and the jump instruction then had to move from 050,205 to 225. So now that we've done that, now we would, if we were putting this into ROM, we would send it to the programmer, but we're just going to move it. And so let's now copy our code. And again, copy says, where are we moving the code to? We're moving it to 050,220. And what's the block of code that we're moving? We're moving it, our block of code is at 050,200 to 050,216. Okay, now let's look at our code again. Dump symbolic 050,200, 050,230. So I started at 220 so we can see the original code is still there. We just copied it. We didn't move it. So that's our original code. Well, it's the original code after it was translated. So our jump is going to 050,225. And then you can see our new code is at starting at 050,220. I guess I didn't catch all of that. DPS 050,220 to 050,230. Oh, I guess that's probably the same thing I did before. Third time's a try. Okay, so there's our new block of code completely moved, plus a little extra. All right, so that's the monitor. Everything except for the PROM program, and I can't show you that because I still haven't placed that order for DigiKey for my new transformers. I keep thinking that there's something else I'm going to want, and you don't remember that until right after you place the order, so I keep delaying that. But anyway, this is if you're using the monitor, these are the instructions, and hopefully this gives you an idea as to what you're looking for when you do things. And remember that when you're loading octal, the little trick that you got to put in the slash and then a space and then start your octal characters, and you always have to have a space between them and put in leading zeros. The edit command, you can, one thing that's kind of nice about the edit command, I'll show you here. If we edit and let's do 050200. One of the things with the edit command you can do is, of course, you can type the space and it will just show you what value is there. And if you want, you can change it. If you don't want to, you can just go on to the next one. But you can use the caret to move back one. So you can see this moves the location counter, or the location up one if you use the up caret. You can also, from the edit, you can use the @ sign to execute the program. And so this will automatically, this is the same as exiting and then typing the execute command, the XQT, and we can just go from 050220. And also from in the editor, you can just, if you decide you want to cancel out, you can just do a, once you're in, you can just type an R to cancel out of the edit. And that's the extent of the editor. All right, so now that's everything I had to say about the monitor, and it's, it looks really simple, but boy, I tell you, these are some nice, powerful features, particularly the disassembly, the ability to enter the mnemonics directly and the arguments. It's really a pretty sophisticated monitor, and it's really is going to make it a lot more fun to use this system. That's it. If you have any questions, let me know, but thanks for watching. Bye-bye.